So use the table in the data to approximate the rate in hundreds of entries per hour at which entries were being deposited at time equals 6. So this is asking for the instantaneous rate at time equals 6. Well, since we're not given an explicit function, we're not going to be able to differentiate a function and plug in 6 to find the rate. So we will need these 2 points, which is the points between time equals 6. So the slope between these 2 points represent the instantaneous rate of change at time equals 6. So E prime of 6 will equal the change between these 2 points, a secant line between those 2 points. So we can do 21 minus 13 over 7 minus 5, which equals 8 over 2, which equals 400 entries an hour. Now, this is part A, and this is worth 1 point. And don't forget your units, which is represented in hundreds of entries per hour. So, in part 2, we're asked to approximate this value using 4 subintervals of a trapezoidal sum. So what we're first going to need is we're going to need to find the area of a trapezoid. What's the formula for that? Well, it's just your height divided by 2 times your 2 bases. Okay, in this case, our height's varying, so we're going to need to add multiple trapezoids. So our first height is 2, so it's going to be 2 divided by 2 times your 2 bases added together, which will just be 4, plus 5 minus 2 is 3, so 3 over 2 times 4 plus 13 is 17, plus 7 minus 5 is 2 over 2 times 13 plus 21, which is just 34, plus 21 plus 23 is 44, and times just 1. So we get this, right? 10.687. So 1 point will be setting up your approximation, and another point will be your actual number. And make sure you round correctly, because on the AP test you must round to 3 decimal places. Okay, so part 2 of part B just asks us, what does this mean? We don't need to know any numbers, we just need to explain. And this is going to be 1 point of part B. So part B is going to be a total of 3 points. Now, what does this 1/8 mean? Well, whenever you see out in front of the integral, 1 divided by something is 8 minus 0 is 8. So notice that this is going to be 1 over your upper limit minus your lower limit. This means it's going to be the average value of this integral. Now, what does the integral represent? Well, the integral represents the amount of entries in hundreds of entries in the box between a certain time period. In our case, our time period is 0, which represents noon because it is given, and time 8, which is 8 p.m. So it's going to be the average number of hundreds of entries in the box between noon and 8 p.m. Okay, so in my opinion, part C is the hardest question, because not only do you need to computate numbers, you need to know what they're asking for. They're not asking for you how many were processed, they're asking you how many were not processed. So that means you're going to have a number minus how many were processed. So in our case, by 8 o'clock, there were 230 entries, right? So we need to subtract 230 minus our integral from 8 to 12 of our function p of t. So that's going to look like 23 minus your integral of 8 to 12 of t cubed minus 30 t squared plus 298 t minus 976 dt. So this is a calculator section, so we're not going to actually need to do this all by hand. So when you put this in a calculator, you're going to get 16 for this part. Now, that is not the answer. 16 is not the answer because that is the amount that were processed. So the amount that weren't processed were how many were there total at the beginning. They only processed 16 between this period, and there were 23 to start with. So 23 minus 16 will be how many were not processed between the time period 8 and 12 p.m., which equals 700 entries. Part D asks us for when the entries are being processed most quickly. Okay, so what does most quickly mean? Well, that, in math terms, is an absolute maximum of our function. In our case, our function is p of t. Now, with an absolute maximum, you need two endpoints of your domain, and you need to set the derivative equal to 0 to find your critical values. And then you can test points to find where your y value will be the highest. And wherever your y value is the greatest, that will be your absolute maximum, as long as that number is within your domain. The x value is in your domain. Your critical values must be in the domain, because if they're not in the domain, those y values don't matter. It has to be between 8 o'clock and 12 p.m. We don't care at 7 o'clock at 1 in the morning. Okay, so how do we find the critical value? So we set the derivative equal to 0. So now to solve that in our calculator, we're going to go solve. We're gonna do in terms of x, because doing in terms of t, your calculator doesn't care what you do it in as long as you put it in terms of that variable. So we'll go 3x squared minus 60x plus 298 equals 0. Now this next part is very important. You need to do it in terms of x. So you're solving in terms of x, right? So they're going to give you these. These are exact numbers. Now, on the AP, they're going to want you to round. So in order to get an rounded answer, you have to go menu, number, approximate to decimal. And it's going to give you x equals 9.1835 or x equals 10.8165. So we're going to round that to x equals 9.184 and x equals 10.817. Okay, so right now we have 4 possible values where absolute max can occur. X equals 9.184, x equals 10.187, x equals 8, and x equals 12. Now, the next part is to plug these numbers into our original function, not the derivative. We're plugging this into the original function because we want to see what the greatest value is of that function. We don't care about the derivative. So whatever your y value is the greatest, that time will be your absolute max. So they're not asking for a y value, they're asking for the time. Now in terms of points, your first point is if you consider the derivative equal to 0 to find your critical value, so that's 1 point. Now, your next point is if you identify your candidates for an absolute max. So you're going to have 4 candidates, your critical values and your endpoints. And then your next point is going to be the answer, which is 12, and you need to justify. And another way you can justify is